All right, so let's talk about the product rule for exponents, which says that a to the x times a to the y is equal to a to the x plus y. So we'll do a couple examples. So for example, 3 squared times 3 to the 5th would give me 3 to the 2 plus 5, which is 3 to the 7th. M to the 4th times m to the 21st would give me m to the 25th. Five p to the 3rd times 2p squared. I would multiply the coefficients first, and that would give me 10. And then I would apply the product rule for exponents to the pieces that have exponents, so that would give me p to the 5th. I can use this rule in the other direction as well to say, for example, that x to the 4th is the same thing as x to the 3rd times x. Because remember, there's an invisible exponent of 1 here. I could also write x to the 4th as x squared times x squared. The product rule can be helpful in cases where you are evaluating something with a big exponent. So for example, I might not know what 2 to the 6th is, but I can rewrite it as 2 to the 3rd times 2 to the 3rd. And I know that that is 8 times 8, which is 64. So that's an example of how the product rule can be helpful. Let's talk about the quotient rule for exponents, which says that a to the x divided by a to the y equals a to the x minus y. So for example, 3 to the 5th divided by 3 squared would equal 3 to the 5 minus 2, which is 3 cubed. K to the 9th divided by k to the 7th would be equal to k squared. Ten m to the 23rd divided by 5m to the 15th. First, I'm going to divide my coefficients. So that would give me 2. And then I'm going to apply the quotient rule to the terms with exponents. So that would give me m to the 8th. I can also apply this rule in the other direction. So b to the 7 is equal to b to the 10th over b cubed. So let's talk about the power rule for exponents, which says that a to the x raised to the power of y is equal to a to the power of x times y. So for example, 3 squared raised to the 4th power would be equal to 3 to the power of 2 times 4, which is 3 to the 8th. M to the 4th raised to the 7th power would be equal to m to the 28th power. K squared raised to the power of x would be equal to k to the 2x. And we can also apply the rule in the other direction. So for example, 2 to the 6th, I can rewrite as 2 to the 3rd squared, because 3 times 2 is 6. Then I know that this is 8 squared, which is 64. So using the product rule can help you manage numbers with big exponents in that way. So let's talk about the power of a product rule for exponents, which says that a times b to the x is equal to a to the x times b to the x. So for example, 3x squared is equal to 3 squared times x squared, which is equal to 9x squared. 2k squared raised to the 3rd power would be equal to 2 to the 3rd power times k squared to the 3rd power, which is 8 times k to the 6th. Three ac cubed is equal to 3 cubed a cubed c cubed, which is 27 a cubed c cubed. And we can also apply the rule in the other direction. So for example, 3 squared times 2 squared is equal to 3 times 2 squared, which is 6 squared, or 36. 4x to the 4th is the same thing as 2 squared, right, because 2 squared is 4, times x squared squared, because we would use the product rule, so this would be x to the 4th. So that is the same thing as 2x squared squared. Okay, let's talk about the power of a fraction rule, which says that a over b to the power of x is equal to a to the x over b to the x. So for example, 3 halves to the 3rd power would be equal to 3 to the 3rd over 2 to the 3rd, which is 27 over 8. X over 4 squared would be equal to x squared over 4 squared, which is x squared over 16. We can also apply the rule in the other direction. So for example, 27 squared over 9 squared is equal to 27 over 9 squared, which equals 3 squared, which is 9. So the negative exponent rule says that a to the power of negative x is equal to 1 over a to the power of positive x. So for example, 3 to the negative 2 is equal to 1 over 3 squared, which is 1/9. This rule also means that if we have a negative exponent in the denominator, if we move that term to the numerator, the exponent becomes positive. So for example, 1 over 4 to the negative 3 is equal to 4 to the positive 3 over 1, which is 64. So x to the negative 2 over y to the negative 3 would be equal to y to the positive 3 over x to the positive 2. Three y to the negative 6th would be equal to 3 over y to the positive 6th.